In the last section, we talked about among all possible lines passing through the centers of the data, it is that particular axis which has maximum variance. Means when you put projection on that particular line from all data points, the projection points where the perpendiculars are cutting the line has maximum variance. Let's apply the same concept to a 3D case. So here is a 3D case about which I want to talk to you. So in this case, let's imagine the data points are in the space very much like it as the shape of the human being. So imagine each of the molecule of this particular human being is like a data point. Now if I ask you to apply the same definition here, how will you apply? So first point, it was all about that you have axis passing through the center of the data points. So here is the center of the data points and you have three axes. One axis is like this, another axis is like that, which is like representing width, this is representing height, and you have the third dimension which is representing depth. Depth is like this particular dimension. Now if you apply that definition which we talked just now, where we are talking of like when you put projections the variance is maximum, which dimension do you think is the first principal component? Obviously if you look at and you start putting projections from all data points to this particular lines, the variance will be going to be similar to this much distance. Whereas if you start putting projection on this particular data point, the variance is going to be very much like up to this point. Whereas if you start putting projections on the line which is representing depth, the projection will be varying probably here to here, this much kind of variance. So it is pretty obvious that this particular line, this particular axis will represent the first principal component. Among the residual variance, obviously this is bigger than this one, so this represents the second principal component and this represents the third principal component.